and welcome to class. This is Mr. Michael Ezanata, and today we'll be considering the topic mensuration of solids. If you will, you can say mensuration of 3D shapes. You have 2D shapes and three-dimensional shapes. Of course, your 2D shapes are the plane shapes, the ones you normally draw on paper. But when a shape has a third dimension, which is the height or the depth, it becomes a solid. So this is the topic, mensuration of three-dimensional shapes or solids. So we're going to be looking at the different solids that we have. We'll look at their key properties and the formulas that we need to note about them. So we're going to do that for so many of the solids before we'll even get to the calculation aspect of it. So for today, let's consider a few of them. The first one we want to look at is the cube. So let's look at the cube. Okay, now I'm going to go ahead and make a drawing of what the cube looks like. So if you are not sure of how that can be done, follow my lead. So we're going to make a square. Okay, so I'm going to draw a square. Okay, that's a bit okay. Now having made it the square shape, you have to make another square inside of the one you made, something like this. So I'm going to make another square. Oh, that's okay. Then the next, for you to connect the lines, draw from here to here, connect here, connect here, and connect here, and we have a cube. Well, yeah, so that's a cube. So we want to study the cube, and we're going to consider the cube under the following topics. We want to find out the number of faces it has, number of edges, the number of edges it has, the vertices, okay, the volume, let me use V for that, the volume as a formula for the volume of a cube. And of course, so we're going to consider what is known as the total surface area. I'll call that a TSA, which I'll explain what that means in just a second. So we're going to consider the cube under the following: the number of faces it has, the edges, the vertices or the vertex for singular, the volume V, and then the total surface area. Let's start with the faces. Okay, to help us with that, let me quickly change. We're going to let's letter the faces. So let me select this. Okay, so let's label this. So we have here a we have a B, we have a C, here we have a D. Okay, and here we have E, F, we have the G here, and the H here. Okay, not really in the alphabet. The lettering is a bit, but I hope you can see that. So we have the lettering A, B, C, D, E, F, G, H. So if we want to count the number of faces that this has, what we have to do is, now one face, we have A, B, C, D, that is a face. We have another one, A, C, E, G, that's another face. And we have, so let's try to label them. So we have A, B, C, D as 1. We have A, C, E, G as 2. We have B, D, F, H as 3. We have the back side now. which is E, F, G, H as 4. Then let's label the top and the bottom. The top, that's A, B, G, H, that's still 5. And then E, C, D, F as 6. I hope you can be able to make out what we've been doing so far. So this means that your cube has 6 faces. So the number of faces that a cube has is 6 in number. Alright. Okay, very quickly before I do that, let me clean up a bit. So we have that our cube has 6 faces. Okay, we'll go over to the edges. Now, what is an edge? The edge is really the straight lines, that you have on your cube. That is, for example, your AB, that's an edge. BD, that's another edge. CD, that's another edge. AC, and all that. So those are the edges. So let's make a quick count to see how many edges I will have. So we'll have AC, that's 1. AB, that's 2. BD, that's 3. CD, that's 4. CE, that's 5. DF, that's 6. EF, that's 7. EG, that's 8. FH, that's 9. AG, that's 10. BH, that's 11. GH, and that's 12. So this means that the cube has 12 edges. Alright, so a cube has 12 edges. Now over to the next one, the vertex. What's the vertex of a cube? We want to consider the vertex. Now the vertex, you want to see it as the point where three straight lines join or connect. That will be a vertex, where you have 3 straight lines joined together as a junction, or in the node where 3 lines intersect. You might want to call that your vertex for singular and vertices for plural. So if you want to count the vertices that a cube has, that will be where we have the lettering. So we have this point A1, B2, C3, D4, E5, F6, G7, and 8H. So those points, they are what we call the vertices. Those are the places where you have the lines, the node or the junction where the lines connect, and there are 8 of them in a cube. So it means our cube has 8 vertices. So have 8. Now we'll go over to the volume of a cube. Now, so you would know that the volume is given by the length times the breadth times the height, or the length times the width times the height or depth, if you will. So let's look at, but our cube, it has 6 faces and they are all equal. So when the faces are equal, it means that the length, the breadth, and the height are all equal. So let's label here length to be L. Okay, let me use another color for that. So label here the length is L, the breadth, let's say call it L, the height still L, because they are all equal, as you have that your cube is made up of square faces. So using our volume formula, which means the length times the breadth times the height, so we'll multiply the length times the breadth, which is still length, times the height, which is still length. What do we have? That will give us L raised power 3. Okay, so we have the formula derived that the volume of a cube is given by the formula L cube. That's the volume of a cube. So whatever the length is, raise it to the power of 3, and then that will give us the volume. And of course it has to have the unit, cubic unit, of course, your cm cube, meter cube, and all that. Alright, now the next one that we'll consider is the total surface area. Now the total surface area of any shape is gotten by adding up all the faces in this case, the flat surfaces, the areas of the flat surfaces that we have around the shape, when we add them all up, that will give us a total surface area. When we go to some other shapes like cylinder, cones and all that, you see how we can calculate their surface areas. But for a shape like a solid like a cube, we have to calculate the area of the lateral faces and then add them up. That will give us the total surface area. As we already know, our cube has 6 faces, so what we need to do is to calculate the area of those 6 faces, add them up, that gives us total surface area. But again, our cube is made up of 6 identical faces, so what we need to do is just to calculate the area of one face, then multiply by 6 or add it into 6 places. That will give us the total surface area. So quickly, let's do that. From our diagram here, the length area of any given of a square is given by length times breadth, area length times breadth, and in this case the length is L and the breadth is still L. So for the area of, say, the face ABCD, if you want to calculate this face ABCD, the area of it would be the length times the breadth of it, which is still L. That will give us L squared. So that means that the area of each of the 6 faces is L squared. So for the 6 faces, what we need to do is simply to multiply 6, standing for the 6 faces, times L squared, which is the area of one face, and that will give us 6L squared. So from this we have derived a formula for the total surface area of a cube, and that is 6L squared. Now this is the convention, the naming convention I've used for this particular lesson. In some textbooks you might see it has been 6x squared or 6c squared or whatever the case may be, but this is just the logic behind it. So you can choose to call the length anything. If I had used x, or we'll be having a 6x squared. So this is just, don't be confused by the naming convention that you might come across in different textbooks or other study materials. Just understand what is going on. So this is, we have looked at the cube, the number of faces it has, that's 6, the edges 12, the vertices, there are 8 of them. The volume of a cube is given by your L cube, and the total surface area, that is a summation of all the lateral surfaces of the cube, that will give us 6L squared. And of course the unit has to be in square unit, as your cm squared, meter squared, as the case may be. Alright, so that is that about the cube. Eventually we'll get to solve some problems on all these shapes, but for now we're studying them. Want to find out things like this and the formulas that are necessary in our mensuration of solid shapes. Now let's go over to the next solid. The next solid that we'll look at is similar to the cube, and this is what is known as the rectangular prism, or the cuboid. So let me write that down. So we want to look at now the cuboid. Okay, so we have the cuboid. Let's look at the cuboid. Now the cuboid, let's first of all make the drawing of what a cuboid look like. Now your cuboid, if you want to talk about shapes that have that are like your cuboid, that would be your carton, your match stick, the box, and so many other things that you have around you. For the I forgot to mention that of the cube. The cube has a perfect example of a shape of a solid that has shape of a cube is your seasoning, your Maggi cubes. Yeah, the cube, Maggi cube, your sugar cube, yeah, cube of sugar. Those are examples of your cube. For your cuboid, you have the cartons, your Indomie pack cartons, your matchstick, the box. Those are shapes that have a cuboid shape or a rectangular prism. So let's quickly make a drawing. If you know how to do that, you can go ahead and make a drawing. But if you don't know how to do that, follow my lead as I do that. So we need, in this case, a rectangle. For a cube we'll have to draw a square, but for a cuboid we'll need a rectangle. Okay, so let's make a rectangle. I think this is very obvious. So we'll make the rectangle, then another rectangle inside the one halfway. So, oh no, that didn't work out as I wanted. Okay, so let's make another rectangle, cover it up, something like this. And then we'll connect the lines, connect the lines, and we have our cuboid staring us in the faces. All right. Well, okay, to create some space, let me try to adjust this. Let me see. Okay, right, yeah, okay, so we have our cuboid drawn. Now we're going to consider, still under the same headings, want to find out the number of faces it has. Oh no, want to find out the number of faces it has, the number of edges, the vertex, the volume, and then the surface area. So I want to consider the cuboid under this following heading. So okay, let me go ahead and also label it this time around as well. So let me use blue in this case. All right, so let's label the sides here. Let here be A. Okay, let's see. We have A here, we have B, we have C, we have D, E, F, G, and H. Alright, now for us to identify the number of faces that it has, still just like we did for the cube, still the same way. So a face, for example, would be A, B, C, D. That is a face. Another face could be A, G, E, C. That's a face. E, C, D, F. That's another face. So when we want to count the number of faces that it has, let's identify. This is 1. All right. Let's go to the opposite, the back side of it. So we have another one here, making it 2 faces. Let's consider this left hand side as G, A, C, E. So we have here, that's 3. The opposite of it, that's H, B, F, D. Come over to this side, that's 4. Then let's consider the top and the bottom, that's A, G, H, B, A, G, H, B, that's 5. And of course C, E, F, E, that will give us 6. It means that our cuboid or the rectangular prism has 6 faces. So let me quickly clear that up. So we have for the face, number of faces 6. Now for the edges, we're going to be quick about that. Just like your cube, now you will note that your cuboid and the cube, they have some similar properties. So for the edges, that's a straight line. So A, B, that's one edge. AC, AD, BD. So if we make a quick count, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has 12 edges. Let me clean that up. So our cuboid has 12 edges. Now for the vertices, remember that's the point where 3 lines meet as a junction, the node where 3 lines intersect. So we have the lettering A, B, C, D, E, F, G, and H. So those are the points where you have the vertices or the vertex for singular. So you have 6 of them. All right. So our cuboid has vertex 6. And didn't quite work out. So it has 6 vertices. Okay, now the next is the volume. Remember that the volume is given by the formula length times breadth times height, or length times width times height. But for our cuboid, it may look at the shape, will tell you that they have different lengths. The length, the breadth, the height, they are not the same as we have in the cube. So let's label here length. Okay, let me use a different color now. So this is the length, and let's call here the breadth B, the breadth of it, and H, the height of it. Oh, let me write it here, the height of it. So if we want to calculate the volume of a cuboid, that will give us the length times the breadth times the height, which will give us altogether LBH. Therefore, the volume of a cuboid or a rectangular prism is given by the formula LBH. Okay, so our volume in this case is LBH. Right, let's consider the surface area now. So for our surface area, just like we did for the cube, the surface area will also mean the summation of the areas of all the 6 faces. Alright, so let's take it one at a time. Now there are 3 distinct faces that we have on this cuboid. The first one is this face, and this face, you have it here at the front and then at the back somewhere here. Alright, you have it there at the front, then at the back. That's the first distinct face that we have. The other one we have the one by the side here, which also happens to be the same here. Alright, so those are that's the second distinct face that we have. Then the last one, let me see which color I can use now. Maybe I use black. Okay, so we have black is already in use. Which color can I use now then? Okay, let me use black. The top side, so let's have here, and here. That's another distinct face, which also happens to be the same one that we have down here. Alright, so we have a cuboid having 3 distinct faces, which are called twice. They are called twice, so each of the faces are called twice. That will give you altogether 6 faces, but 3 distinct faces. So we'll have to calculate the area of those 3 distinct faces. When we get them, double for each of the areas to make up for the 6 faces. So let's take it one after the other. Let me clean up. Let's start with this face. Okay, let's start with the front side. Let's consider the face ABCD. ABC. No, let me change color. Let's consider ABCD. So we have ABCD. Now the length of it is L. The breadth of it will become H in this case. That's our height. So we have L times H, and that will give us LH. Now mind you, this face appears twice, at the front and at the back, so the area for these two sides will give us 2LH. Alright, now let's consider the side. 2LH. Let's consider the side now. That's this one here, which also appears here. Alright, so the length for this, we can use B, and then the height of it is H. So the area will be B times H. That will give us BH, and because there are two of them, that will give us 2BH. I hope this is visible enough. And then of course the last one is the top of the bottom. Now if we want to consider the bottom part of it, that is this one here. Now if we want to consider that part, the length is L while the breadth of it is B, so the area for that will give us length times breadth. That will give us LB, and because we have two of that face, the bottom and then the top part of, topmost part of it, that will give us 2LB. So all together, the total surface area of your cuboid will be the summation of these, that is the areas of the 6 faces. So that will give us 2LB plus 2LH plus 2BH. This is the formula for the total surface area of a cuboid, or the shortened abridged version of it, because you have 2 is common to both sides, so we have it to be 2 into bracket LB plus LH plus BH, where your L stands for the length, the B stands for the breadth, and the H stands for the height. So once you get the values of your length, the breadth, and the height, plug it into the formula. When you're done, you put your square unit for area, as whether cm square or meter square. So our surface area in this case is 2 into bracket L, not sure I can be able to squeeze that in, LB plus LH. Oh no, that wouldn't squeeze in. Let me make it okay, you already have it down here. Okay, you already have it down here. So this is, let me not try to go and squeeze this so we don't enter. So this is the surface area of your cuboid. 2 into bracket, bracket open, LB plus LH plus BH. That will give you the surface area of a cuboid. Okay, so I'll pause the video. We'll stop here for now. In our next video, we'll continue with other solid shapes. We'll consider a pyramid and other ones that will have the cylinder, the cone, and others. So until the next video, stay safe. Bye.